Hi there. Today we will talk about mean, especially for geometric mean. Let's have an overview about mean. As we all know, mean is the most common basic statistics term. People are questioning, are there any types of mean? The answer is a yes. There are different types of mean. In here I give 3 types. Those are arithmetic mean, geometric mean, and lastly, for sure, harmonic mean. We already know and we're used to about arithmetic mean using, and we have found it in some applications in our daily life. But now, we will focus on the geometric mean side. Geometric mean, GM, is not the same mean we used to know. We just simply added all the values, then divided by the numbers of data, like I have shown the formula below. Do you know the work of it, or any statement that comes into your mind? If you doesn't have any idea to say for it, and still confused about it, then it's your right place to watch and learn about it. Let us begin. What is geometric mean? Geometric mean is an average which indicates the central tendency or typical of a set numbers by using the product of their values. The geometric mean is the end root of the product of all the values. The formula geometric mean is the end root of all the values by multiplying all of them, where end root you found it through the total number of values in the data set. The differences between geometric mean and arithmetic mean. The main difference over here is the way it is calculated. The several other differences are below. First, GM is known as multiplicative mean, and AM is additive mean. Second, GM is multiplying the numbers and taking the end root, while for AM is the sum of all the numbers divided by the numbers of data. Third, GM is more effective and accurate where there is a lot of volatility, percentage change, and AM is more accurate results when the data sets are not skewed and not dependent on each other. Fourth, GM is always lower than AM due to compounding effect, and AM is always higher than GM as it is calculated as a simple average. Fifth, GM is found in calculating the portfolio returns in finance, and AM is found in everyday calculations with uniform set of data. 6. GM is applicable only for a positive set of numbers, while for AM can be calculated with both positive and negative sets of numbers. Lastly, the geometric mean must be used when working with percentages, while arithmetic mean works with the values themselves. Properties of geometric mean. First, the GM is less than or equal to the arithmetic mean. Second, all the data values must be positive. Third, if every element in the data set is replaced by the GM, then the product of the objects continues unchanged. Fourth, the geometric mean of the ratio of two variables is equal to the ratios of the GM. Lastly, the geometric mean of the product of two variables is equal to the product of their GM. There is a term that called inequality of arithmetic mean and geometric mean, or we can say it AM-GM inequality. It states the arithmetic mean of a list of non-negative real numbers is greater than or equal to the geometric mean of the same list, and further, then the two Means are equal if and only if every number in the list is the same. Advantages: it is rigidly determined. The calculation is based on all the terms of the sequence. It is suitable for further mathematical analysis. Fluctuation in sampling will not affect the GM. It gives relatively more weight to small observations. Disadvantages: GM cannot be calculated in the case of negative or zero value of any variable in the series. If any of the observations is zero, the GM becomes zero, and if any of the observations is negative, the GM becomes imaginary. Due to complex numerical character, it is not easy to understand and to calculate for non-mathematics person. That's why it is not commonly used method. The value of geometric mean cannot be obtained in the case of open-end distribution. Applications: the geometric mean is employed in many of the value line indexes used by financial departments. It is also used in stock indexes. It is used to compute the annual return on the portfolio. It is used in finance to calculate average growth rates, commonly known as compounded annual growth rates. It is employed in research on cell division and bacterial development, among other things. Example: this is the question. The return on investment earned by MACD for 5 successive years from 2017 until 2021 was 16.8%, 19.86%, 19.35%, 10.19%, and 15.14%. What is the geometric mean rate of return on investment? First, we need to make a list of the data. So given 16.8% in 2017, 19.86% in 2018, 19.35% in 2019, 10.19% in 2020, and 15.14% in 2021. The value of n, we get it from how many years that are in the data. So from 2017 until 2021, it has 5 years in between. The question being asked is the GM rate of return on investment. Solution: Step 1. Change the percent into decimal. We will divide it by 100, so the results become 0.168, 0.1986, 0.1935, 0.1019, and 0.1514. Step 2. Add 1 to the numbers. So it becomes 1.16.8, 1.1986, 1.1935, 1.1019, and 1.1514. Step 3. Insert the numbers into the formula. GM is equal to the fifth root of multiplying all the numbers. We get 1.1621. Step 4. Subtract 1 from the resulting value, so 1.1621 minus 1 equals to 0.1621. Step 5. Change the resulting value into percentage by times 100. So 0.1621 times 100 equals to 16.21%. A second application of the GM is to find an average percentage change over a period of time. The formula: GM equals to and root of value at end of period divided by value at start of period minus 1. Example. Question. Users of LinkedIn increased from 78 million in 2010 to 690 million in 2020. Find the geometric mean annual percent increase. Given value at start of period is 78 million in 2010 and value at end of period is 690 million in 2020. The value of n is 10 because we get it from the subtract between 2020 with 2010, so it equals to 10. What we need to find is the GM annual percent increase. Solution. Step 1. Insert the numbers into the formula. So the 10th root of 690 million over 78 million minus 1, it equals to 1.2436 minus 1, it equals to 0.2436. Step 2. Change the resulting value into percent by times 100. So 0.2436 times 100 equals to 24.36%. Summary of GM. GM is the end root of the product of all the values, where n is the total number of values in a dataset. The main difference between GM and AM is the way it is calculated. The main properties of GM are GM is less than or equal to AM, and all the data values must be positive. One of the advantages, it is rigidly determined, and one of the disadvantages, GM cannot be calculated in the case of negative or zero value of any variable in the series. Example of the applications are in stock index, compute the annual return, and average growth rates, and bacterial development. That's all for the geometric mean lesson. Thank you for listening and watching this TV. Hope it will be useful for you.